Hello and welcome to Unit 9, Day 3 video notes. We're going to be talking about surface area in the next couple lessons. And so I wanted to give you a rundown of these different figures that we're going to be looking at. And we're talking about 3D figures, or we will also call those solids. Okay, figures in geometry that have 3 dimensions we can call solids. All right, sorry about that interruption. And so we need to be able to talk about the surface area, or the total area of all surfaces of these figures. Now today we are focusing on these 2 figures only, prisms and cylinders. We will eventually talk about pyramids and cones, and then also spheres. But right now we're just talking about these 2. So I'm going to describe what these figures are. A prism is a solid with 2 bases, that's very important, that are congruent and parallel. The bases have to be congruent and parallel for this to be considered a prism. All right? And in any prism, the bases are always the shapes that are congruent and parallel. That makes the bases these triangles in this case. And that is not always the case. It's not always the top and the bottom. All right? In this case it is, but if I were to take this paper and turn it, okay, this is still a prism, but this, what appears to be on the bottom after I've turned it, is not a base. The bases are these triangles still. It doesn't matter if it's laid on its side like this, or the way you originally see it on the paper is up and down. Okay, the bases are the congruent parallel shapes. And so a cylinder is a prism with circular bases. That's all it is. And then the sides are not just one solid flat side, they're this curved side. And so we'll talk about all the rest of these in a little bit, but I wanted to point out some of these examples that were prisms and cones. Okay, so we're going to skip past 1 and 2. I'm sorry, prisms and cylinders. Skip past 1 and 2 and look at number 3. Number 3 we call a triangular prism because the bases are triangles. Okay, number 5 is the next one I want you to look at, and that is a cylinder. Okay. Number 6 is a prism. We call this a rectangular prism. Okay. Because the bases are rectangles. Now, in a rectangular prism, any 2 opposite rectangles could be the bases. So it could be the bottom and top rectangles. It could be the left and right rectangles, or the bases could be the front and then the back rectangles. On number 7, though, because we have these 2 shapes at the front and the back that are not rectangles, these are trapezoids, those have to be the bases. Okay, we can't call the top and bottom the bases. These 2 parallel sides have to be the bases. Okay? And so this is what we call a trapezoid with the letters AL at the end, prism. Okay. We're going to skip number 8 and look at number 9 now. This is another prism where the bases are these congruent parallel pentagons. These 5-sided figures at the bottom and top are called pentagons. So this is called a pentagonal or pentagonal prism, because this first word describes the bases. And then the last one we want to talk about is number 11. This is another triangular prism. Okay. And very quickly I'm going to go back through these that we've talked about and highlight what the bases are. Okay. In this triangular prism, these triangles are the bases. In the cylinder, the circles are the bases. And on this rectangular prism, any 2 opposite rectangles can be bases. It doesn't have to be top and bottom in that case. It could be. Number 7, the trapezoids at the front and back are the bases. And then on the pentagonal prism, the pentagons at the top and bottom are the bases. And then on number 11, the triangles at the front and back are the bases. Okay? So those are prisms and cylinders. And now we're going to take a look at how to actually calculate surface area. Okay, so we're going to turn the page, and this is where we're going to begin the main content of our notes today. All right. All right, now to talk about surface area, you're going to notice that I'm giving you some formulas on this page, but these formulas will not be given to you to use on the test. And so I'm actually going to show you a slightly different way to calculate surface area. And for the sake of time in the video, we're not going to cover every single example. All right? So the surface area of a figure is always the total area of all the surfaces, all the sides that you could touch if this were an actual three-dimensional object sitting in front of you. Okay? And so on a rectangular prism, you'll notice that it's a very simple formula. There are two length times width measurements, okay, because there's a rectangle on the bottom measuring length by width, and then its opposite counterpart on the top is also length by width. So there's two of those. Length times width here, another one up top. That's why there's two. And so we do 2 times length times width. But then the same is true for length times height, these sides here. Those are also rectangles. There's 2 of them. And for the top and bottom, the front and back, width times height, we get that. But really, all you have to do is add up all of the areas of the individual sides. For rectangular prisms, it's really easy to follow this formula. So for number 1, okay, it doesn't really matter which one you call length, width, and height. So I'm going to call 7 the length, 13 the width, and 9 the height. So I'm going to have 2 7 by 13s, or 2 times 7 times 13, plus 2 of the 13 by 9s, so 2 of the 13 times 9 areas, and then also 2 of the 7 times 9 areas. And that's how I get surface area total. Okay? So when I start to multiply these, 2 times 7 times 13 is 182. And 2 times 13 times 9 is 234. And 2 times 7 times 9 is 126. And so when I combine all of those areas, I get a total of 542 square feet. Okay? And so that's what we would do. On number 2, we could call 10 the length, 16 the width, and 5 the height. And it doesn't have to be in that order. We could arrange that a lot of different ways, but that's what we would plug into for those numbers. So we're going to do the bottom and top rectangles areas, the front and back rectangles areas, and then the right and left rectangles areas, and add them all up. So we're actually going to skip over 2 and 3. Okay. We're going to take a look at when we have any other kind of prism when it is not a rectangular prism, when the bases are not rectangles. Well, the easiest way to think of this is as a composite figure. Okay, we're just going to add all the individual areas. Okay? And there is a formula you can use, but we're kind of going to ignore that. Don't cross it off or anything, but we're just going to do this a little bit more simply so you don't have to think and remember all these formulas. Just add up all the areas. Now, I always want to start with the bases. There's always going to be 2 bases in a prism. And so I'm always going to start with 2 of the base areas. Okay, in this case, that is a triangle. All right, so the area formula for a triangle is base times height all over 2. Well, since it's a right triangle, I can call the base of my triangle B, 9, and the height of my triangle, 12. I've got 2 of those. But you'll notice when they're triangles, this 2 with this 2 on bottom, those can actually cancel, so we can save ourselves some calculations. Okay, but then I have 3 rectangles. Okay, the sides that form this figure we call lateral faces. Okay, the non-bases are called lateral faces, because lateral means side. So we have 3 of those. We have a 15 by 16 rectangle, so 15 times 16. We have on the back a 9 by 16 rectangle, because all of these segments vertically on your page are 16. And then I'm going to have to wrap it around down here. I also have a 12 by 16 rectangle on the back. And so I'm just going to total all of these things up. Okay, the first part, 9 times 12, because the 2's canceled. Now if you multiply by 2 and divide by 2, that's okay. I'm just telling you you're going to get those to cancel in your calculations. 9 times 12 is 108. 15 times 16 is 240. And 9 times 16 is 144. Now I also have to add in 12 times 16, which is 192. And so now I need to add all 4 of these pieces together to get my total surface area. And in doing so, I get a total surface area of 684 square meters. Okay, so once again, you're just adding up the total areas of all the surfaces, kind of like our composite figures lesson. Okay, we're going to skip over number 5, and I'm going to have you do most of the work on number 6. So I'm going to get it set up for you, but then I'm going to have you push pause on the video and try and calculate it yourself, and then you can check your work with the answer I showed you. So here's what we're going to do to set this up. The bases are these parallelograms at the front and back. So your surface area starts with 2 of the area formula for trapezoids. Okay, there's a trapezoid at front, trapezoid at back. And remember, that is height of the trapezoid times the sum of the bases divided by 2. The height of each trapezoid is 12. The sum of the bases, the 2 different bases, are 18 and 23. So we write 18 plus 23. And that's all over 2. Once again, the 2 and 2 cancel here, just like they did in the triangles problem above. Okay, so we can cancel those 2's. But then we're also going to add the 4 rectangular areas going from front to back. Okay, so that would be 12 by 15, 18 by 15, 20 by 15, and 23 by 15. So I want you to write those out and find the total surface area. You're going to want to pause the video to do it all on your own, and then you can click play to check what the answer should be. Okay, if you need more time, pause again, but this is what you should get. 1,587 square feet. Once again, okay, we took our 2 trapezoid areas, and then these are all the areas for the rectangles making up the sides. Okay? All right, these 4 other sides. And so we get these totals that we add together to get that. Okay, we're going to skip over these 2 examples. We're going to skip over 7 and 8. Okay, and we're going to talk about cylinders, and it works out very much the same way. We're going to find the areas of the 2 bases. So surface area for each one of these is 2, and then the area formula for a circle is pi r squared. But then we're also going to add in this curved surface. If I were to cut this out, think of taking a can and cutting off the circles and cutting down one side and opening it up, you would get a rectangle. Okay, where that rectangle is the circumference of the circle long, and then the height of the cylinder wide. So the other part of our formula is 2 pi r for circumference. Okay, that's your circumference of the circle, times the height. Okay, so we kind of do need to use this formula in this case. But either way, we're just using the height of your cylinder and the radius of your circles.